So what I have here is the so-called MacBeath Poncelet N equals 3 Poncelet family of triangles, the blue triangles. These are interscribed in an outer black circle and circumscribed an elliptic caustic, this brown caustic here, for which one of its foci is the center of the outer one. So, this is X3, the circumcenter, and you get, by virtue of properties of inconics, that the other focus has to be the orthogonal conjugate of X3, which is the orthocenter. And the center is the midpoint between circumcenter and orthocenter, so the center is at the 9-point center, the Euler circle center. But this is immaterial to what I'm about to explain, and that is what I'm doing here is I'm inverting the caustic on the circumcircle, and then I get this outer bean-shaped thing. It looks like limaçon of Pascal, but I don't think it is, but it could be. I'm inverting an ellipse with one of the foci at the center, and I'm getting this outer curve. And then I'm inverting each one of the side lines with respect to the circumcircle, and I'm getting these three outer circles here. Now, as I animate this thing, one thing that one notices is that, so there are two interesting properties. Number one, the centers of these three circles, the locus of their centers is a circle. So I would love to prove that. And the second property is that the sum of their radii raised to -2, so 1 over square of the radii, is conserved. So that's quite interesting, right? I'm just going to leave this as a couple of observations, and I'll see you on the next video.